Today's topic is infrared spectroscopy. First question: what is spectroscopy? The branch of science which deals with the study of interaction of electromagnetic radiations with matter is called spectroscopy. When an organic compound is IR radiated with electromagnetic radiations, the organic compound can absorb some specific frequencies and allow the remaining radiations to pass through it. Some of the light can also reflect it back to the source. Effect of ER on molecules. At high frequency, short wavelength, and low frequency, long wavelength. So, what is infrared spectroscopy? The branch of science which deals with the study of interaction of infrared radiation with matter is called infrared spectroscopy. During interaction of infrared radiations with matter, vibration in bond take place. Further, different bonds respond by vibrating very slower, medium, or faster. This response can be detected by an instrument and converted into a visual representation called a infrared spectrum. Now, types of molecular vibrations. Infrared radiations cause stronger molecular vibrations in covalent bonds. Specific bonds respond to specific frequencies of IR radiations. Covalent bond can vibrate in several modes. First, stretching vibration. The vibration in which the distance between the two atoms increase or decrease, but atom will remain on the same bond axis is called stretching vibration. Note, stretching vibration are the most useful vibration in IR spectra. So, types of stretching vibrations. First, symmetrical stretching. The stretching in which both atoms move in or out with respect to central atom. Second, asymmetrical stretching. The stretching vibration in which one atom move in and other move out with respect to central atom. Asymmetrical stretching require more energy than symmetrical stretching. So a band of asymmetrical stretching appears at higher value of frequencies or wave number. Second, bending vibration. Vibration in which distance in between two atoms remains same but position of atom changes. So types of bending vibration. First, in plane bending, the vibration in which the atoms remain in the place of system. Now, types of in-plane bending. First, scissoring, the vibration in which the two atoms approach toward each other in same plane. Second is rocking, the vibration in which the two atoms move to the same side of the same plane of system. Second, out of plane bending. The vibration in which the atoms moves out of plane of the system is called out of plane bending. Now, types of out of plane bending. First is wagging, vibration in which the two atoms simultaneously move above or below the plane of system is called wagging. Second is twisting, vibration in which the one atom move up and other move down the plane of the system. Next is principle of infrared spectroscopy. During interaction of infrared radiations with matter, change in vibrational energy level take place. So, IR spectroscopy is also called vibrational spectroscopy. As each vibrational energy level is associated with larger number of rotational energy levels with much smaller energy gap, so radiational transmissions also take place along with vibrational transitions. Hence, vibrational spectroscopy is also called vibrational rotational spectroscopy. Further, all the bonds in a molecule cannot absorb IR radiations, but only those bonds of molecule will absorb IR radiations which are accompanied by a net change in dipole moment, and such transitions are called IR active transitions. So, what is the condition for IR spectroscopy? It states that the fundamental vibration will be IR active in those compounds which have bonds having net value of dipole moment. Or it states that the any substance will absorb IR radiations and undergo vibrational transition if it has bond with net value of dipole moment. For example, heterodiatomic molecules like HCl, HBr have bond with separation of charge and this bond has net value of dipole moment. So they are IR active. Second example, homodiatomic molecules like H2, O2, N2, etc. have bond with zero value of dipole moment because they have no separation of charge. So they are IR inactive. Next example, in symmetrical polyatomic molecules like ethane, ethene, ethine, etc. There is a bond with zero value of dipole moment because they have no separation of charge. So they are IR inactive. Further, there are bonds with net value of dipole moment. So they are IR active. In IR spectra in ethane, carbon carbon bond is symmetrical alkene, that is ethane, are not accompanied by net charge in dipole moment. Hence, carbon carbon bond of ethane molecule will not absorb IR radiations, but CH bond in ethane is asymmetrical stretching. Bending vibrations are accompanied by a net of dipole moment, will absorb IR radiations, and such transitions are called IR active transitions. Next example, the propane is IR active because the bond moment of the CH bond do not completely cancel the bond moment of the other CH bond and thus it has net value of dipole moment, while ethine is IR inactive because the bond moment of one CH bond completely cancels the bond moment of the other CH bond and thus it has net zero value of dipole moment. Next example, the cis 1,2 dichloroethene is IR active because the bond moment of one CCl bond do not have completely cancels the bond moment of other CCl bond and thus it has net value of dipole moment. While trans 1,2-dichloroethene is IR inactive because the bond moment of one CCl bond completely cancels the bond moment of other CCl bond and thus it has zero value of dipole moment. Next, fundamental vibrations. So, what are fundamental vibrations? The vibration which correspond to the first vibrational transition on absorption of IR radiations is called fundamental vibrations. Overtones. What are overtones? Any multiple of fundamental vibration on absorption of IR radiation is called overtone. So, what is first overtone? The vibration which occur from zeroth vibrational level to second vibrational level on absorption of IR radiation is called first overtone. Second overtone. The vibration which occur from zeroth vibrational level to third vibrational level on absorption of IR radiation. Calculation of number of fundamental vibration. So for non-linear molecules, number of fundamental vibrations will be 3n minus 6. For example, in benzene C6H6, number of fundamental vibration 3n minus 6 is equal to 3 into 12 minus 6 is equal to 30. Another example for this is chloroform CHCl3. The number of fundamental vibrations is equal to 3 into 5 minus 6 is equals to 9. Next, for linear molecules, number of fundamental vibrations is equals to 3n minus 5. For example, nitrous oxide N2O. Number of fundamental vibration is equals to 3n minus 5, which is equal to 3 into 3 minus 5, which is 4. Now, in CO2, theoretical number of fundamental vibrations are 4, but CO2 give two vibrational band on one symmetrical stretching is IR inactive. One asymmetrical stretching is IR active. Two bending vibrations are same and give bond at same value.